Okay, so do you remember the three forms of the quadratic vaguely? Do you remember me talking about it at least, that there are three forms of the quadratic? So you can leave your finger on this page, but I'm just going to show you what I'm referred to what I'm talking about. On page 3, way at the beginning, I kind of introduced the notion that we have the general form, the descriptive or vertex form, that's what we're going to talk about right now, and then the factored form. Okay, so the reason why we don't really care too much about which form this is in is because we can type any quadratic, any equation into our calculator and just graph it. So it doesn't restrict us to not really identify the forms at first, but part of this unit is for you to be able to recognize the forms and to work with it and to extract information without graphing. Okay, so we're going to park on this one right now, descriptive or vertex form. So go to 15. Okay. So recall that the general form has no brackets. It looks like this. So if you don't have brackets, okay, general form has no brackets and it will look like that. Okay. The vertex form, however, has brackets. Okay, so now we're going to talk about that vertex form. What does it give us just by looking at it? It still tells us the direction of opening and the width, and this is new, right? It can immediately, just by looking at it, you can tell how many x-intercepts it has and what the vertex is. Okay, it looks like this. This is what it looks like in general. Where A still gives us the direction of opening. Okay, and it gives us the width that we're expecting. Same as before. Okay, this is same as before. So no news there. A is always at the front, in front of the bracket with the square, right? So we can, from that, just right away tell this is opening up or down. Okay. And here's another, I'm going to use a red pen for this. And we can also tell the vertex from it. So basically what you will be doing is you'll be looking at whatever h is, okay, and you will change the sign of it. That's what we do in math. We go negative h. And so basically I will make an arrow to that negative and basically say that it changes the sign from equation. Page 15. And notice that K stays the same. So K, this right here, you just copy paste it into the coordinate of the vertex, and so whatever that number is, that the constant that's just flying solo here, it's not inside the bracket, you copy and paste that. The h here, right, the h there, you would change the sign. Change the sign of it if you want to state the coordinate of the vertex. So, here are some examples. All of these have a bracket with a square on top, so we know it's vertex form. Direction of opening. This right here is A, right there. That is A. And it's -1. So A is equal to -1. So direction of opening, this will be pointing down. That's what we would expect without even graphing it. The width, because A, the value of A is 1. Okay, I know it's -1, but we just look at the value without the sign. This is a normal, what we call a normal width. Okay, it's not going to be super wide. It's not going to be super narrow. It's kind of like that standard width that we're expecting. Not terribly important because we can just type it in. The vertex, this is where it changes. Okay, vertex. What will go in here? Okay. It's positive 4 here. So this will be negative 4, 5. Okay, negative 4, 5. If you want to just highlight that positive 4 in here and then say it turned negative, it kind of like, it stands out, right? The y-intercept. Can we just get the y-intercept off of this just by looking at it? Just by looking at it, can we say, oh, it's 5? The answer is no, it's not 5. So you have to use your calculator for this one, okay? Use calculator. It's not in general cal. What am I doing here? You can use your calculator, or you can just plug in, you let x equal to 0. So can we go ahead and graph this real quick? I mean, if you just want to watch, that's fine. But I go negative, bracket, x plus 4. Make sure you do this squared on that one. Okay, if you don't raise it to the power of 2, you're not going to get the right answer. Plus 5. I'm going to graph this, and there it is. I'm going to find the y-intercept. Second trace value, x is equal to 0, and the y-intercept is negative 11. Okay, so don't be falling for, oh, it's the 5, because you're so used to the general form, the last number being the y-intercept. So we're going to go second trace value. Okay, x is equal to 0, so it's 0, negative 11 is our y-intercept. Okay. I'm going to let these two, I'm going to give these two as for homework right now. Homework or class time once I'm done this lesson, okay? I want you to just fill that in and be able to answer those questions. And the key will be posted here. And I feel like I need to give you a note here because it happens way too often. If equation is not in general form, and I just give my students this hint, brackets, okay? If you see brackets, you know for sure it's not in general form. Okay? Don't think that the last number is your y-intercept, that constant. Use second trace value, x is equal to 0, to find y-intercept. And I'm going to highlight this here. And I'm gonna try to test you on that in the days to come. Like, hey, what's the y-intercept? And I hope that you'll realize, wait a minute, there's a bracket there. This is not in general form. I can't just say that last number is my y-intercept. I can't. Okay. Keep going. 16. And one more time, because right now you don't see the vertex form, I'm just going to show you one more time. Okay, that's what I'm referring to, the vertex form. If A and K, so when it comes to the number of x-intercepts, okay, you were looking at A and K the whole time, right? So if A and K have the same sign, no x-intercepts. You're not going to have them. Folks, you need to know that if the vertex is somewhere up here, anywhere up here, we know that K is going to be positive. Like K is the coordinate, the y coordinate of your vertex. So if you're anywhere in here, okay, you know that K is positive. And if A is positive, right? A is positive, we'll make this point up. Here, K is positive, which is, remember, this is HK. The vertex has coordinates HK when we're dealing with the vertex form. So if K is positive and A is positive, this is never going to cross the x-axis, so we would never have an x-intercept. On the other side, on the other hand, if you're somewhere under the x-axis, anywhere in here, K is negative. So if the vertex is somewhere in here, we just look at the K value here, and A is negative. This thing is never going to cross the x-axis. So if A and K have the same sign, it's just never going to happen. Can I just go back and look up here real quick? HK, will go K positive here as well. And for this one, I'm going to go HK, K will have a negative sign right next to it. So it's just never going to happen. If A and K have opposite signs, then you have two x-intercepts. I'm going to use a different color for this one. If they have opposite signs, you've got two x-intercepts. Meaning, if the vertex is somewhere in here, K would be positive, right? If it points down, A is negative. So if the signs of A and K are opposite in any combination, but if they're opposite each other, you're going to have two x-intercepts guaranteed. And last but not least, if K is equal to 0, the sign of A does not matter. There's just one x-intercept. If K equals to 0, can we go next to the x-axis here and just say K equals to 0 means that we're somewhere on it, right? It's not positive or negative. The y value of the vertex means you're right on it. So you might be here. A might be negative. It doesn't matter. There's only one x-intercept. Or K is right on the x-axis here, and A is positive. It doesn't matter. You just have one x-intercept. I will give you an example of this one in particular. Y is equal to negative 2x minus 4 squared. And technically, there is no K here. But I want you to think of that technically there is K just trailing along. It's just 0. Okay? Meaning you're right on the x-axis. You're not above or below it. Okay? Okay, let's put this to the test, what I just talked about here. Make sure you copy this down, right? You're having this down. So in these instances, folks, I'm going to ask you to explain how you know. You can verify using your calculator. You'll be like, oh, I know, Mr. Dirksen, I can clearly see that there's 2 here. But I'm going to ask you to explain it, right? So here you have to say what? A is negative 2. K is negative 5. Sorry. K is negative 5. Sorry. Why double negatives? There we go. K is negative 5. Okay. The vertex, let's state the vertex before I do this interpretation here. What is the vertex of this particular parabola? It's going to be negative 4, negative 5. Okay. So let's sketch this real quick before I use this to explanation here. Just a sketch. Negative 4, negative 5 is where? Negative 4 would be somewhere here. Negative 5 would be somewhere there, right? Would put me in this. This is where the vertex is. Which way is this pointing? It's pointing down, right? So you could technically, just by observation, just by saying, oh, this one gives me the vertex, I got that. The vertex is over here, and it's pointing down. This is never going to cross the x-axis. So that's one way to put it. But you can just say here, since A and K have the same sign, there are no x-intercepts. Okay, so that's that. What about this one here? Let's extract our vertex out of that. How do you know, Mr. Erickson, this is in vertex form? Because I see the bracket and I see a square there. So this is a quadratic in vertex form. What's the vertex here? What will be the first coordinate here of my, it'll be positive 3. I'm actually going to go positive 3 there. Okay. You bring this over, change sign. Change. Yikes. Are you okay, Mr. Erickson? It's Monday, okay? Leave me alone. Change sign. Okay? So you change it from a negative to a positive, and then the -6 stays. Like you never change the sign of that constant there. Okay? So if you wanted to sketch this, where's 3 -6? 3 -6 is somewhere over here. And A is positive. Okay? So this is going to actually cross the x-axis twice. Okay? So A is positive 4.8. K is -6. Right? Since they have opposite signs, we would expect 2 x-intercepts. So it's all about the sign. Okay? Time is running out here. I still would expect you to know how to do this. Calculate the y-intercept algebraically. What does that mean? It means by hand. You need to show me how you did that. So for this one, right, we let x equal to 0 in a sense. We let x equal to 0, and that's it. And then you just solve for y. So here, we would go y is equal to -2. I'm going to use a red pen for the 0 plus 4 minus 5, and clean it up. Okay, -2, 0 plus 4 is just 4. You square that, minus 5. Y is equal to -2 times 16 minus 5. That's -32 minus 5. That's -37. So what did you just find? You found the y-intercept, that when x is equal to 0, y is equal to -37. That's what I mean by doing this algebraically. And we've done some of this before. This is a review. We have done this. It could be a value other than x equal to 0 as well, but for y-intercepts, that's what we always use. We use x is equal to 0. I want you to try the other one as well, okay? You try. So this is part of your homework. And I will just post the key to all of this stuff, all these pages. So I want you to take this one up here, bring that down, and find your y-intercept there. And I'm just going to say this. 17 to 18. So you can cross the whatever pages are down here. I used to have a textbook. I don't have a textbook anymore. I'll just say homework. Basically anything that hasn't been done from 15 to 18. There's some graphing on page 18. That is not a word problem, guys. If it's not a word problem, we include all 4 quadrants, okay? All 4 quadrants if there's no word problem attached to it. All right, so you can use the rest of the class. How about you fill in that table and you do this one, the Y-intercept, before the bell goes, and then you try the pages that follow at home.